So I studied engineering at the University of British Columbia in Vancouver in Canada. So I grew up in Canada, so I studied at university there. And after I graduated, I got on a plane and flew to Scotland. And the very first job I was offered in Scotland was back in the days, there used to be something called Silicon Glen in Scotland, where we made microchips. So you can see on the left-hand side of this picture, a person holding what's called a wafer, which has all the silicon chips. And these chips are what make your computer work and your phone work. Everything digital has one of these inside. And we made a lot of them. We still make quite a lot of them in Scotland. And we were working on some new technology to make something called MEMS, which are micro machines. So those are machines that are so small that they are embedded onto a microchip. Absolutely tiny things like mirrors, tiny things like levers. You can use them, micro channels, you can use them for testing in medicine. There's lots of different things you can do with these tiny microscopic machines. So that's a picture in front of you. The middle picture is one of our bigger machines that I designed and my colleagues and I built in order to make these little micro machines. And on the right-hand side is me at work. Because everything is so very tiny, you have to work in clean rooms. And so you can't have any skin particles or hair particles or makeup or anything like that that might get on that lovely shiny wafer. So you have to wear this clean suit all of the time. And so that was my first job when I moved to Scotland. One of the things that I've been lucky enough to do as an engineer is I joined a trip to Antarctica. So now that I work in politics, and I'm sure everybody's aware of this, about climate change and about preventing our planet from heating up so that we can still continue to live on it and continue to have all the wonderful wildlife, penguins, elephants, polar bears, all the wonderful things that live on our planet. So I traveled to Antarctica with women from all over the world to study climate change and to learn about being a leader in climate. And we got to see, you can just see in the background of this picture, some penguins, and we got to see the ice sheets of Antarctica. So that was an amazing opportunity that I had as part of my old job. And this was before I got elected, the last thing that I did was working on a tidal turbine. So I moved away from those silicon wafers into renewable energy, and specifically what we call marine renewable energy. So that's the energy that's in the sea. So using waves and tide, because the tide flows in and out twice a day, and you can capture that energy a bit like you do with a wind turbine, and you can channel that and turn it into electricity. And so we were working on the world's largest floating tidal turbine. So this is a picture of me in a factory in 2020. So we were trying to build this during the COVID pandemic. So we all had to be masked and distanced and all that stuff while still being at work. That's me and some of my colleagues, and we finished at this point building it. This is called a power nacelle. So the front of it, the distant part you see on the right-hand side there, where the round bits are, that's where the blades go on, and that front bit rotates. And then inside the big cylindrical bit behind us, that's where the generator is that will actually turn that rotation into electricity. So it's all sealed up in that steel box so that it can go in the sea. But what I want you to remember about this picture is how big that big nacelle is compared to us four little people in the front. Remember that, because it's going to be important in the next slide. So then that was built in Germany. We brought it. This is the nacelles arriving in Dundee, at the port of Dundee, because that's where we did the next stage of assembly before we launched it and towed it up to Orkney. Now, this is a drone that we put up into the sky to look down on the turbine. And now you can see that the nacelles are just these tiny things on the end. That's how big the whole turbine is. It's as big as a ship. It's simply enormous. And you can just see a couple of tiny people down on the left-hand side of the picture to give you an idea of how enormous the whole thing is. So it looks a bit like a spaceship. And here's the last picture, and that's it being taken out to sea. So we took it out to sea, put it in the water, it floated. I mean, it was designed to float, but it's always comforting when it actually floats and doesn't sink to the bottom. It floated perfectly, and we towed it up to Orkney. So around about that time was when I got elected to the Scottish Parliament. So I didn't get to be involved with getting it switched on, but my colleagues did a really good job, and they got it switched on and working, and it's generating electricity now.
That's brilliant. That was, and that picture at the end, the size of that is just mind-blowing. Obviously, anybody who has any questions who's here, please, like I said, use the Q&A function. But just to pick up on a couple of the things that you were mentioned there, Lorna, if I can, while we wait for those questions to start coming in. So you were part of the Homeward Bound expedition, wasn't it? That was the one to Antarctica. What was that? What was the process like? Because I think you were one of only 3 scientists from Scotland who were able to go and take part in that. So what was that like?
It was completely amazing. So it's a project that's running over 10 years. And the idea is that over 10 years is to make a network of 1,000 women scientists and engineers all around the world, so that we have those connections and the knowledge we need to bridge the gap between what scientists know is happening to the planet and what governments and politicians simply aren't doing. And I was part of the 3rd group. So I was in the 3rd year who got to go with that. So there were 80 of us on that, 80 participants and 10 people doing the teaching and organizing. So 90 of us all together. We spent 1 year studying. So it was a bit like taking a master's degree. We spent a year studying and doing group projects the way, like you would with any class or course. And then we all got on a ship and sailed to the Antarctic. And that was a sort of 3-week intensive where we were spending long days studying, again, working on projects, but we did get a few hours each day to go out and see Antarctica, to experience that environment. And one of the reasons to go to the Antarctic is because you can see so clearly there the effects of climate change. Already there are bare patches in Antarctica where you see bare rock and bare water, where there used to be snow and ice. I think since then, I went in 2019, and since then, I think we're starting to see more evidence of climate change, actually, even in our own country now, with how warm the weather is, with some of the terrible storms we've had. But even 2 years ago, it wasn't quite so bad here. So going to Antarctica and starting to see those changes was really emotional and affecting. But I mean, it's quite alarming that we're now starting to see changes even in our own backyards as the climate warms up.
Completely agree with you on that. And as you've been answering that, we've started to get quite a few questions coming in. So I'm going to pick up, we've got one of our schools who's taking part in Jersey on the Channel Islands. They wanted to know the tidal power system that you were working on. How many homes would that power? And with their tidal ranges in Jersey, would they be able to make use of something like that to help them on the journey to achieve net zero?
You might well do. So I'm not familiar with the tidal resource. So that's the word we use, tidal resource, to determine whether you have some. So generally speaking, the best tides, the ones we can use, are between island groups. So the tide often flows a bit like a river between island groups. And if you have an arrangement like that near your island, yeah, it's very possible that that could be the case. Of course, there's always some complications with using the sea like that, because you may have fisheries that are in that area, or marine protected areas, or some other reason why maybe that isn't the best place to put a tidal turbine, because it's of course really important that we take all of those things into consideration. But yes, absolutely. Scotland has a lot of this stuff, but there are opportunities around England and Wales as well. I don't have the numbers in front of me for exactly how many homes that tidal turbine would power, but what I can tell you is that when it was up and running, the previous version, so this is the second one of these that we built, it could run up to 25%, so 1/4 of all the energy use in Orkney. So the Orkney Islands, home to about 25,000 people, I think, something in that area. So during the daytime, when people are using a lot of electricity, we could provide about 9%, but at night when people are using lesser, it was more like 25%. So it's significant. It's a big chunk of electricity. And at the moment, there's only a few of these in the world, these tidal turbines. The technology is fairly new. We're well ahead in Scotland in terms of being able to build this stuff. And just like you now see wind turbines everywhere, in the future, we'll see a lot more tidal turbines.
And just to finish off their questions on that as well, so does that, when it's in place, does it have an anchor? Does it stay in place, or does it float and move? And what's the lifespan of the generator?
Those are excellent questions. I love solid engineering questions. So that's quite a technical answer for how it stays in place. So the tide will flow on the turbine, it floats, and the tide tries to push it away, because the tide flows like a river. So yes, it has to be anchored to the bottom. It's anchored by something called a catenary mooring system. So if you do a Google for that, you'll see what that looks like. But that's very heavy chains coming from the bottom of the turbine, down into the seabed where we have very heavy anchors. So big chunks of concrete and old chains and basically anything really heavy that we can hold it down with. And so what this chain does is it hangs in a sort of curving shape. And that allows the turbine to move back and forward in the tide, because of course the tide goes two directions. First it flows this way and then it flows that way. And the other thing it does, because the chain provides a bit of damping motion. So if you've ever been out in a boat, you'll know that when a wave hits your boat, it's quite a jar, like it slaps you like that. Now, if you had that hitting your machinery a lot, your blades and your generator and stuff, you would break your equipment. So what you need something to soften the blow a bit, and we call that damping. So that chain, that little bit of movement, allows a bit of damping. So when waves hit the turbine, there's a bit of give in the system, and that helps protect the equipment. So that catenary mooring system does some clever stuff. If you're into that kind of thing, mooring system is a whole science, and we had one whole engineering team. They still have, or Orbital Marine Power still have one whole engineering team that is devoted to designing moorings. It's a very important thing.
Wow, brilliant. Right.
And the turbine should last 25 years. We designed it to last 25 years, but with good repair and maintenance, it can go a lot longer.
Brilliant. That's really, really interesting. I'm going to move. So I've got questions coming partly in the chat and partly in the Q&A. So I'm going to try and make sure I cover both of them off. So I'll start with some that have come through the Q&A. So we'd like to know what inspired you to do engineering, and what age did you start getting into engineering?
I was 13 when I started getting interested in engineering. I was quite an intense kid. And I remember lying awake one night when I was about 13 thinking, oh, I hadn't decided what my career was going to be yet. And I was quite stressed out about it. So I thought and thought, and I decided that I liked those films where, astronauts go up into space and there was, all the kind of control rooms and stuff. So I decided I was going to be an astronaut. So the next morning I got up and I wrote to the Canadian Space Agency and said, what do I need to do to be an astronaut? And they did what I'm sure they do for all precocious children. They sent me a whole bunch of leaflets and pictures of astronauts, and they were very kind. And in their letter to me, they gave some of the examples of what kind of careers astronauts had had before they became astronauts. And some of them were doctors and some of them were scientists, but most of them were engineers. So I thought I'd hedge my bet. And so from the age of 13, I knew I would go off and study engineering, because I wanted to be an astronaut. I didn't get to be an astronaut. I did apply, but I didn't even get through the first, I never even made it through the first level, sadly.
Yeah, I think, I know certainly in school, astronaut was one of the things I was thinking of too, and I thought, I'm never going to pass some of those tests. I suppose that actually answers one of the next questions, which was whether or not you always knew that you wanted to be an engineer. But then who would you say has been your biggest idol?
Oh, now that is an interesting question. One of the problems with being a woman in engineering is there aren't any, or weren't any, when I was growing up. So I've always been, or nearly always been, the only woman where I work. So it's very difficult to have a role model, because there is no one for me to look at and think, oh, I'm like her, because there isn't anyone that's like me. So that's been a big challenge. But I've been very lucky in my career that I've worked with, unfortunately all men, but they have been wonderful men who, we have always had a very respectful relationship. And I always feel like, I hope these things are changing so that we have more women in the field. But I always felt I was just one of those little anomalies that people get used to. It would be a bit weird having a woman in the team, and then they would all get used to me and it was fine.
Brilliant. I don't know whether you got that. Sorry, I think
no, sorry, I think we just froze up a wee bit there.
Yeah, that's fine. Just the question that I was just asking was whether you've ever been hurt when you've been engineering.
No, I've never suffered an injury. Health and safety is really, really important, especially when you're offshore, but also in those clean rooms. From the pictures when you saw in the first place, in those clean rooms, we were dealing with some very dangerous chemicals, dangerous acids, dangerous gases. And of course, at sea, when you're working with a turbine or when you're doing that kind of construction with cranes, you're lifting, you're using paints and other chemicals. So safety is absolutely our number one concern. I have written lots of health and safety risk assessments, and I've been on lots of training courses for working at height, for how to safely lift things. So fortunately, I have never been injured, nor have I worked with anyone who's been injured. And fingers crossed that's the case, because the safety aspect is the most important.
Brilliant. So how many hours did you work on the project for the tidal generator? How many hours of work did that take for you? That's the next question that we've got coming.
So that's years of project work. So generally speaking, I would say that when doing those kind of big machines, you spend about 2 years designing. If it's a new technology, you spend about 2 years designing it. So that was a team of about 10 people, because we had some people designing the moorings, people designing the steel structures, people designing the blades, people designing all the electronics. You have to buy all that stuff. You have to choose who you're going to buy all the different pieces from. So that's a big team project. It took about 2 years for us to design it, all those people working full time, and then about a year to build it. So about 3 years from saying, right, let's do this, to switching it on.
Okay. And obviously, I think so since last year when you were elected to become a representative, and to obviously then in August when you became part of the Scottish Government, we've got a question as to whether or not you miss the hands-on aspects of being an engineer now that your day-to-day is as a member of the Scottish Parliament.
I really miss it. I mean, I did that hands-on engineering for more than 20 years. So that was my main career. It's been a big process of adjustment to doing something different. I mean, there was also an element that with the tidal energy, as I was saying, there aren't very many tidal turbines in the world, and there's only a handful of people who've ever built one. And it was nice to be considered an expert. People used to listen to what I say and not argue. But of course, in politics, disagreement and arguments. Nobody's an expert. Everybody's about coming, looking at the data together and coming. So it's a very, very different environment. So I'm having what they call a steep learning curve to learn my new job.
Brilliant. So the next question we've got is whether or not does it run within your family? When you were growing up in Canada, did you have other family members who were involved in engineering, and what did they do if they were?
No, nobody in my family is an engineer. My family tend to be artists. I've got uncles who are writers and painters and musicians. My mother's a teacher. So no engineers at all. I'm the only engineer in my family.
Okay, so then this has come in then, and that's perfect. What advice do you then have for any young engineers? Or what advice would you give to, in fact, no, that's a slightly different question. I've got two questions for younger generation. So we'll do the one around advice for young engineers first, and I'll come to the next one after that.
Well, I mean, my advice for young people in general, we're coming to that one, aren't we? So yeah, for young, if you already know that you're interested in engineering, then, I mean, there's lots of things you can do already. I'm sure your schools have competitions for, building, I don't know, Lego robots or any of those. Those are always good fun. Absolutely do that. And you need to study the right subjects to get into engineering at university. I'm not so familiar with the process here in the UK because I did it in Canada, but I'm sure it's maths, physics. You need good language skills, because something that I think people miss and don't understand about engineering, which is maybe one reason why people don't go into it, is engineering still requires really good communication skills. It requires good problem solving and creativity. It requires really good teamwork. So if you're good at that, if you like working as part of a team, if you like communicating with people and sharing ideas and solving problems and coming up, because the thing with engineering, you're coming up with solutions that no one's ever had before. No one's ever done this before. So there's an enormous amount of creativity that's required. And I think that sometimes people think, oh, engineering is not very creative, but it's enormously creative. It's enormously collaborative. You're working all the time with really interesting people. So those are the kind of things I want to emphasize about it. Although you do need to get the right grades in maths and physics and so on, you still have to have all those other skills. And there is space in engineering for people with all different skills. There are some people that sit in front of data sets and computers all day. That's not what all of us do. Some of us get out and meet people. We, go and get to see fantastic equipment. We work with our hands. There's all different ways you can be an engineer.
Brilliant. So then the next question for of advice for the younger generation is a bit more linked towards climate change. So what advice would you give to the younger generation regarding climate change? And if you were giving advice to adults, would it be different to the advice you'd give to the younger generation? That's a brilliant question, that one. So
it is a really good question. And I think it is really different advice that I give to young people and adults about climate change. Because adults ask me all the time, oh, how do we get kids to care about climate change? And my answer is the kids already care. The kids know about this stuff. They get it. It's the climate strikers, the student climate strikers striking every Friday who have made the climate agenda mainstream. People like me who've been in the Green Party, the Green Party's been on for 30 years and they spent 30 years ignoring us. If we'd have started tackling the climate crisis 30 years ago, when we first knew it was a problem, we would have only had to make tiny changes. to prevent it. But they ignored us. And it's taken young people, it's taken Greta Thunberg and all the climate strikers to finally bring it to the world's attention that we now have to do really dramatic things to prevent the climate crisis. So I think young people get it. It's the adults that don't get it. The adults go, oh, but we don't like change. Why should we change? And they just don't understand the scale of change. But I know young people get it, and this is the world that they're going to be growing up in. So I guess what I want to say to young people is don't lose hope. We can still fix this. We can still make it better. And there are huge opportunities for you ahead. Your future can be absolutely brilliant. There are so many good jobs, not just in building things like turbines, but forestry, restoring peatlands. If you're interested in nature and growing things, regenerative farming, planting trees, doing all the science around how we restore Scotland's natural environments, how we restore our seas, how we make sure our wildlife thriving. There's going to be huge amounts of jobs in that coming up, and lots to study. If you're interested in animals or plants or the sea, any of those things, study those things. There'll be lots of work in it. And the other part is the what we call the circular economy, which is designing things to last. So there's a whole bit of work around designing things to last, learning to repair stuff. If you're good with your hands and good at repairing things, if you like to think about, well, I'm going to design a toaster that will last 100 years, but you just have to keep replacing these pieces. Development of new materials. There's some really exciting things coming up, and all those kind of jobs will be there in the future, and they all matter. And it isn't just the kind of science and technology jobs, although there will be a lot of those. There's also creative jobs. So if you feel you're maybe a more creative person in the sense of being a storyteller, the stories we tell about our climate and what we value, they matter too. So if you're the kind of person who wants to be a writer or a painter or an actor, you have a part to play as well in the stories we tell about what's important. And I think what's important is our relationships with people, protecting our planet, leaving it better than we found it. I don't think any of us would say working long hours to buy a bunch of crap we don't need is important, and we don't have to live like that. We can live in a world that values the things we think are important. If you're a storyteller, that's where you come in.
Brilliant. So the next question we've got then is, what was your longest project and how long did it take to complete?
Oh goodness, that's an interesting, it probably is that Tidal Turbine, the 3 years. It probably is that a 3-year project, because it's just so enormous. When I was working in the semiconductor industry, you saw the machines were quite a lot smaller compared to the size of a person, and we could build one of those in a month. So yeah, a machine that takes a year, 2 years to design and a year to build is definitely the longest.
Brilliant. And then, and what was the first project when you became an engineer? Can you remember what the very first project that you were involved in was?
I probably can. Well, what I'll tell you about is my master's degree project. So I was very lucky that at the university I went to, they had a program where where I grew up in Canada, we had to pay tuition fees. I know in Scotland, we don't have to pay those. So to help us pay our fees, we used to do an alternate where we'd study for a year and then work and study and work. And that it meant that your degree took longer, but it also meant that you graduated with many years of experience, and it helped pay for it. So while I was doing that, I did a master's degree, and the project that I worked on there was a vending machine for a local swimming pool. So they wanted to people to be able to buy tickets for the pool from a machine, and we designed it with a touch. I think it had a touch screen on it, which was in those days very high tech, because this is a long time ago. This is before smartphones, with a touch screen, and people could come in and press the button and put their money in, and that was great because it had all this sort of coin. Because handling money, there's all these little niche areas of vending, but putting coins into a slot and make sure they actually all roll and don't stick in. There's a whole thing. Anyway, so that was quite good fun.
Okay. And then I suppose another one around projects. What's the most interesting project that you've been involved in?
Well, I have been involved in some very interesting projects. For 1 year, I worked in wave energy before I went into tidal energy. So that's capturing the energy from waves. And those machines look really different than tidal machines. So tidal turbine, tidal energy is much more straightforward than wave, because tides are always there. You know exactly when they're going to be, how strong they're going to be, because you can calculate that, every day forever. Waves are different. Waves are unpredictable. They can be enormous, like a tsunami or tidal wave, or they can be non-existent, totally flat. And you have to design a machine that will withstand all of that. And while doing that, I've seen 5mm plate steel torn like it was paper. Water is so strong. And wave energy there's so much energy there, but how do you capture it without letting it tear your machine apart? And that is such an interesting challenge. And I know there's lots of different wave energy companies looking into that and trying to figure out how it works. And that is really very difficult, but really interesting.
Brilliant. I think we've had a comment from one of our schools who said that the photos that you shared are amazing, and they have asked if you're able to share those photos again. So I don't know if you've got the slideshow to pop it back up again.
Yeah, I can do that.
And I'll carry on. I'll go to the next question while you're doing that, and that's around, obviously, when we were talking about advice with the climate change. One of the questions that's come is asking for a bit more information on what is a circular economy.
Yes, that's a very good question. So here's the slideshow. I'll just go back and see if I can make it go up. Okay, here we go. So that, yeah. Do you want me to talk about the slides, or do you want me to answer the circular economy question?
I think if we keep the slides up, and we'll carry on going through the questions, and we can just go through the slides and show them while we're talking then, so that, I mean, especially ones like that, which is just phenomenal when you see that from above.
So that was the first thing that happened after I was made a minister. My father phoned me up and said, what on earth is a circular economy? So right now, the way our economy works is you buy things, you use them, and you throw them away. So we call that a linear economy. So if you buy your bottle of fizzy drink, and then you throw the bottle away. Well, hopefully you recycle it, but that it's a one-way system. And the problem with that is it creates an enormous amount of waste, literally, in the sense that piles and piles of waste ends up in our beaches and on our parks. I'm sure you can see the litter problem in your local parks, but it also is waste in the sense of somebody had to make that bottle. Somebody had to design it, do the labeling for it, and then you used it once and threw it away. So, we all know that we live in a world of constrained resources. If there's limited resources, we should be using those for the important things in life. We should be using those to make sure everybody has food, that everybody has medical care, that everybody has good education. Why are we wasting so much resource on stuff that we just throw away? So the idea is to address that by making there's lots of different ways we can do it. One is by designing things to last. So when you get a water bottle that you could refill from the tap over and over and over again, that is the circular economy. When you use a reusable mug instead of buying your coffee in a disposable mug, that's the circular economy. When you repair your socks, you get a hole in your sock and you sew it up to make it last longer, or you repair your car, or you repair your toaster. Anytime you repair things or reuse them. If maybe you're getting rid of something in your house, you don't need it anymore, if you donate that to a charity shop, then someone else can use that. And that's that circular economy, so that we're not throwing things away. And if you need something yourself, maybe consider buying something secondhand, or buy something that you know is going to last you a long time, rather than something that you're only going to use for a short while. And there's a lot of interesting things around that in terms of designing products. Like, it's very frustrating when you have something like a Hoover, a vacuum cleaner, that one little part on it breaks and that's it, the whole thing's ruined. What if you could take it to a local repair shop and they could give you that one little piece that you need? And with modern 3D printing technology, that kind of thing is possible. So we can have these repair cafes all over the country that can print you off any part you need, and you can then keep your stuff going. But that means designing in the first place so that things can be easily and safely repaired, creating a catalog of those parts, sending them out to the repair cafe so they can print those parts off. So there's a whole industry to create around preventing waste and making things last a long time. And some of it, I think, is also about quality of life. We were talking about this recently in Scotland. I've introduced in my new job a ban on some single-use plastics, some of the worst ones that we find on beaches all the time, things like plastic forks and plastic knives and stuff. And I think that it isn't just about the waste, although it is, but actually food tastes better when you eat it off a real fork. So there's an element of talking about what we value in our lives. Well, eating nice food properly, that's a valuable thing. So I tend to carry a fork in my backpack when I'm out and about, and I know I'm going to be eating on the run. So that, because it's just nicer. it's about thinking about our quality of life and what's important to us. So I hope that's helpful in terms of saying what the circular economy is.
That's really, really useful. Thank you. I think the next question is, I've got to translate this across different education systems, but if you were speaking to students who were in, I think it was secondary 3 up in Scotland, or year 9 here in across England, and they were making their decisions over which subjects to take forward as they study. Which subjects would you say they need to make sure they include if they were looking at potentially a career in engineering at the end of it?
As I say, I'm also not an expert in this school system here because I was educated in a different country, but I expect that it would be, yeah, maths and physics would be probably the main ones. You probably need a decent English qualification as well. You certainly do in Canada, but beyond that, I don't know. So please do ask your teachers. You probably have a career counselor or some advice you can get. So do get the right advice so that you make sure you don't miss out.
Brilliant. So then just coming back to the Q&A, the next question I've got on here is, what's the most surprising fact or thing that you've learned in your career so far?
The most surprising fact, oh goodness. I suppose it's quite surprising to me that so few women consider engineering. Only 9% of engineers in the UK are women. And actually, here's another one. The UK is short of engineers, desperately short of engineers. That's why you have foreigners like me coming and doing your engineering for you, because we don't produce enough here. So I guess what surprises me is why people don't find it more exciting. This kind of problem solving, genuinely saving the planet, designing technologies that will, working in problems that deal with people's health, the medicine of the future, the technology of the future, tackling climate change, making cities cleaner. All of these things are about making the world a better place. They're about working together with really interesting people. And I don't understand why more people don't find that exciting in general, and why so few women do, because it's really good work. It's interesting, it's well paid. You know every day that you're going to be making a difference, and no 2 days are the same. You're always doing something new and different. So I basically can't encourage you enough to consider engineering or science or any of those technology fields. And something I do want to point out is you don't have to go to university to be an engineer. There are more than one way to do that. There are apprenticeship routes, and there are routes through colleges to get an HNC or an HND. So you don't have to be an academic whiz. If you are, great, go to university and have, you could do that. But you also can be an engineer and have a wonderful career by approaching it from a more hands-on basis. That is really a really good career as well.
Brilliant. And this is, I apologize because this is a slightly detailed question, and certainly very linked to the work that you're doing at the moment as a member of the government in Scotland. It's come from Catenary High School, and they've asked, do you think that the new green era of engineering that's going to be brought to Scotland in order to achieve net zero, should it be done by private companies, or should it instead be done by the public sector? Or is it a combined effort amongst all of the above in order to ensure that Scotland meets the 2045 net zero target?
So, I mean, achieving net zero won't just be done by engineers. There was a good saying I saw the other week that in the future, all jobs will be green jobs. Everybody's job, whether you drive a bus, whether you're a welder or a machinist or a teacher or a carer, you will in the future have a green job, because you will need to think about the waste that your job produces, the energy your job takes, how you heat the space you're working in, how you get the energy to run your tools and equipment, that kind of thing. So all jobs will be green jobs in the future. So we absolutely, all of us have a part to play. And as I spoke about earlier in the conversation, a huge part of that in the future is going to be land and sea-based jobs. So things in forestry and fishing, things in peatland restoration, regenerative farming. There's going to be an enormous amount of that, and of course all the science that backs that up. So that is a big part of tackling the climate crisis. So I don't want anyone to think that it is just about science and engineering. Everybody will have to do this, but science and engineering does have a part to play, particularly in developing new technologies for renewable energy. But actually, as I've always said, the things we need to tackle climate change are largely technologies we already have: wind energy, tidal energy, trains, buses, bicycles. So there's an element of things like redesigning our cities and towns so that we have safe, segregated cycle lanes, so we have better bus services, particularly in rural areas, so that people can leave their car at home, so that kids can cycle safely to school. There's a whole bunch of work there. And of course, that's about city planning and architects, and there's a whole bunch of work there. So there will be in the future more government and more public involvement in this, because coordinating those kind of national plans, and we have devolved parliament in Scotland, and we're looking at national plans to do things like a national care service and do things like upgrade our public transportation all over the country. So these kind of national schemes will require the government to be heavily involved in them, but the people doing the actual work will almost certainly be employed by private companies because they have the expertise and the resources to do that. And they make our economy move. So it will be a mix, is the answer, of public and private interests. Yeah.
Okay. So what's your favorite part of being an engineer? So I know we've touched on whether or not you miss the hands-on, but what's your favorite part for being an engineer?
My favorite part of being an engineer was always the people that I worked with. Engineers are genuinely lovely people because they're very earnest, they care a lot, and it's very nice to work with people who genuinely care about the work that they do and every day want to do the right thing and want to do the best thing, and they're very intense. Engineers tend to be really honest and open as well, so they're fun people to work with, and it's nice to feel like you're part of a team. That's a lovely feeling to come to work every day and know that you're going to be part of a team effort. So that was always what I like to do. When I'm thinking about my day and I'm going to work, it's because I get to work with my pal, or we're going to solve this problem together, and that's what I liked best.
Brilliant. And then the next question that we've got is, how long does it take to become an engineer? I mean, I've always looked at it and gone, you've probably never fully become because you're always learning. But from your point of view, how long do you think it takes to become a fully fledged engineer?
Well, that is a very interesting question, because some people say engineers are born and not made. But I think it's different in different countries as well. So the first thing you would need to get is either some sort of qualification. So maybe that's a served apprenticeship, or it's a HND or an HNC from a college, or maybe it's a degree from a university. So that will depend. That'll be a few years. I mean, I don't know how long an apprenticeship is, 2 years or 3 years. College or university is 3 or 4 years. And then you can go straight into a job. That's fine. Generally speaking, people become a chartered engineer or incorporated engineer if you've come through the HNC or HND route. You don't have to get chartered in this country. In other countries you do, and you would sort of do that mid-career. So normally when you're in your maybe early 30s, late 20s, you would do that. So it depends how you want to look at it, whether you're an engineer from the day you start your first course or your first day on the apprenticeship. I would say you were from that day an engineer. Some people would say you're not really an engineer until you're chartered, and in other countries that's legally the law. You're not allowed to, where I come from, for example, you can't legally call yourself an engineer, a bit like you can't call yourself a doctor or a police officer unless you actually have a certain qualification until you're chartered. Whereas here you can call yourself an engineer at any point. So I think we should be inclusive with that. You could be an engineer from the first day of your apprenticeship.
Brilliant. This is a really interesting question. I think certainly for our schools who have joined us today, who are potentially looking for ideas and looking in the world around them to come up with what solutions they might design and create the ideas for. Where do you get your ideas from to create your projects?
Well, as I say, it's always as part of a team. So my particular area of expertise is in control systems engineering. So every machine has a computer at the heart of it. And whether you're designing a machine for the semiconductor industry or whether it's a big tidal turbine, what you have is a bunch of sensors around the place that take in information from the world, and then the computer makes decisions, and then you'll have some controlling output. So in the semiconductor machines, those sensors were measuring temperature and pressure. They were measuring flows of gas. And then what you decide to do is, if it's too cool, it'll make a decision to turn the temperature up, or to let some more gas in to adjust the pressure, or to let some gas out to drop the pressure down. So those kind of algorithms are what you're doing. And a lot of that is very collaborative. So my scientist colleagues, they would know how much concentration of acid was needed in the chamber. So we would work with them to work out the sort of what we call a recipe for how you would make the silicon chip. And then I would program that into the computer, and I would say, okay, well, we need this sensor to measure that gas, and I would work all that stuff out. But generally, it's a team effort, and it's a process. So engineering doesn't happen. You don't sit alone in a darkened room. These things already exist in terms of how you would do it. There's a sort of set process for defining the problem, understanding what problem you're trying to solve, finding out what tools are available, what kind of computer, what kind of sensors are available. So understanding what problem you're solving, finding what tools are available, and then doing that design work. One of the tools that I always really liked was prototyping. If I was doing something new that hadn't been done before, I would get a hold of, say, probably some old equipment, maybe they'd been lying around, and have a go at wiring it up just to see if I could make it do what I wanted it to do. And then I would show it to people. And you can do this with software as well. You would just throw together something quickly to show it to people, because a lot of times people don't know what they want, but they know what they don't like. So if you ask them, well, what do you want this machine to do? They go, but if you kind of show them what something you put together, and they go, well, I don't like that. You need it to do, that's got to go faster. I find that helpful. So prototyping is a really useful tool when you make something quickly or with sort of leftover equipment, just to see how it's going to work before you make the real one.
Brilliant. So we've got just 3 final questions. So I'll start with, we've touched quite a bit on this, but there has been a question coming about what's the most important thing that secondary students would be able to do to help reduce the impact of their impact of climate change?
So that is a really interesting question. I mean, everything we do matters. Looking at this sort of numbers, I'm familiar obviously with Scotland, but it's probably the same throughout the UK. The #1 source of carbon emissions in Scotland is transportation. Fortunately for young people in Scotland, from the end of January, you will be able to travel for free by bus. So all young people in Scotland will have a free bus pass at the end of January. Now you have to apply for it. So the thing, if you're in Scotland and you're a secondary student, make sure you get your application in for your bus pass, because I think they'll take 10 days to come to you in the post, and we're getting close to the end of the month. So yeah, use the bus, cycle if it's safe to do so, to help reduce those transport emissions. And you know, the next largest source of emissions is agriculture. And I know some people are choosing to eat less meat, or choosing to change their diet a bit so that to reduce the pressure from agriculture. So those are things that we can do in our everyday lives, but also look at how you interact with your city, what you're going to do with your career. You're going to be voting in a few years. I know in Scotland, 16-year-olds can vote. Vote for people who are making the kind of decisions that you want to see made. Make sure you register to vote and go out and vote. And if you're in the other parts of the UK and have to wait till you're 18, still do it. You know, go out and vote when you're 18, because the people making decisions matter. And even better than that, maybe you're interested in politics, maybe get involved, join your local party, stand for election. We could really use more young people in politics. There's far too many people, you know, older people, people who've been around a long time. Some fresh voices and fresh ideas would be fantastic.
Brilliant. So then the next two, these are two really nice questions, I think, to end on. So we'll start with, who would you say is the most interesting person that you've worked with so far in your career, and why were they that person?
Well, I'm in my new job. I work with Scotland's First Minister, Nicola Sturgeon, who is a fascinating person. She's sort of a legend, and I don't get to work very closely with her because government is a big place, but I do get to watch her work when she's speaking in the chamber, and she is such a professional. She's always cool and calm and prepared, and she's so good at her job. So yeah, it's really amazing to get to work so closely with someone I admire so much, and hopefully to learn from her about doing my job. So yeah, that's an enormous privilege.
Perfect. And then the final question, do you enjoy being an engineer? If you find yourself not able to be part of the Scottish government, would you be going back to engineering as your calling card?
That is an interesting question. Would I go back to engineering? I suspect I would probably do something related to engineering. So I did engineering for more than 20 years. And toward the end or later parts of my career, I was doing more management related stuff than I was I still did a bit of hands-on engineering, especially during the pandemic when we couldn't get engineers to site. And I had to remember how to do stuff I hadn't done in 10 years. Because I was the only person there. But yeah, I think I would probably go into more management. I suspect that if I wasn't doing a ministerial role or a member of parliament role, that I would probably do something in that sector. As I was saying, there's going to be a lot of collaboration between the government, between public and private, in terms of, we've got these enormous wind farms we're going to be building off this coast of Scotland, upgrading our rail transport system. I'm sure there's some use for engineering project management and some engineering expertise in those fields. So if I wasn't doing this, I'm sure I'd be doing something like that.
Brilliant. Well, that comes to the end of the questions that we've got. And honestly, I cannot thank you enough, Lorna, for taking the time today, for joining us and for sharing your story and answering the questions of all the schools who've been part of the session today. Thank you to everyone who has joined us live. Don't forget, if you are completing the project in class, you can get those entries into us as soon as you finish them. We are planning the grading days where we're going to get them in front of engineers right around the whole of the UK. But for now, Lorna, I really appreciate your time. I know that the schools who've been with us today appreciate it as well. Thank you very much, and we will let you carry on with your important work as part of the government in Scotland and helping us move towards a net zero economy.
Thank you so much for having me. It's been great.
Thank you. Bye-bye now, and thank you, everyone. Speak to you soon.